Welcome to Direct Preference Optimization. This lesson is part of Module 06, Advanced Topics. Let's get started. Let's now look at Lesson 6.2, Direct Preference Optimization, DPO. Here we can see the DPO versus RLHF. Let's now look at Overview. Here we can see the preference data format. Direct Preference Optimization. Direct Preference Optimization is a breakthrough technique for aligning language models with human preferences without reinforcement learning. Learn to create preference datasets and train models that are more helpful, harmless, and honest. Duration, 90 minutes. Difficulty, advanced. Let's now look at learning objectives. Here we can see the DPO training loop. By the end of this lesson, you will understand direct preference optimization versus RLHF, create human preference datasets, train models with direct preference optimization, evaluate alignment quality, balance helpfulness and safety, iterate on alignment. Let's now look at what is DPO. Here we can see the reward model comparison. Let's now look at the alignment problem. Here we can see the DPO loss function. Problem. Models can be unhelpful, verbose, off-topic, harmful, toxic, biased, dishonest, hallucinations, false claims. Traditional solution, RLHF, reinforcement learning from human feedback, train reward model. Use PPO-RL to optimize. Complex, unstable, expensive direct preference optimization solution. Direct optimization on preferences. No reward model needed. No RL needed. Simpler, stable, effective. Let's now look at DPO versus RLHF. Here we can see the preference annotation guide. Aspect at RLHF, direct preference optimization, untrust complexity, high, 3 stages, low, 1 stage, stability, unstable, RL, stable, supervised, speed, slow, fast, hardware, expensive, affordable, quality, excellent, excellent, use case, large labs, everyone. Why direct preference optimization is better for you. Simpler, faster, works on consumer hardware, Tesla P40. Let's now look at DPO training data format. Here we can see the DPO training progress. Let's now look at preference pairs. Direct preference optimization needs pairs of responses. One chosen, good, and one rejected, bad. Format. Here's the JSON code for this section. Starting with, let's now look at example 1, helpfulness. Here's the JSON code for this section, starting with why chosen is better, specific, actionable steps versus vague. Let's now look at example 2, safety. Here's the JSON code for this section, starting with why chosen is better, refuses harmful request, offers legal alternative. Let's now look at example 3, honesty. Here's the JSON code for this section, starting with why chosen is better, admits knowledge gap versus hallucinating. Let's now look at creating DPO datasets. Let's now look at method 1, manual curation. Best for high quality, specific alignment goals. Create preference pairs manually, add 200, 500 more pairs, save. Time investment, just 5 minutes per pair. Target 200, 500 pairs for good alignment. Let's now look at method 2, generate with AI, GPT-4, Claude. Use AI to generate preference pairs. Prompt for GPT-4. Here's the bash code for this section. Starting with, create 50 preference pairs for training are helpful, harmless, then review and edit the generated pairs. Let's now look at method 3, from existing conversations. Good response, generate a worse version. Bad response, generate a better version. Let's now look at training with DPO. Let's now look at install TRL for DPO support. Here's the PowerShell code for this section, starting with pip install TRL DPO. Let's now look at DPO training script. Load base model, your fine-tuned model. Don't add LoRa again. Use existing LoRa or merge first. If you want new LoRa for DPO, T. Let's now look at DPO training tips. 1. Lower learning rate. Direct preference optimization needs smaller LR than SFT. Here's the Python code for this section, starting with learning Bosch rate 5E5 SOS versus 2E4 for SFT. 2. Beta parameter controls strength of preference. Here's the Python code for this section, starting with beta to 0.1, standard. 3. Batch size, direct preference, optimization processes pairs, needs more memory. Here's the Python code for this section, starting with per, device, train, batch, JOS size, 2, Yo versus 4.8 for SFT. 4. Training time, usually 1-3 epochs is enough. Here's the Python code for this section, starting with numtrain.epochs3. More can cause over-alignment. Let's now look at evaluating DPO alignment. Let's now look at before versus after comparison. Load before DPO, base model. Load after DPO, aligned model. Generate from base model. Generate from DPO model. Test alignment improvements. Expected improvements, more detailed, structured responses, better refusals of harmful requests, more honest about knowledge limitations, maintains creativity and helpfulness. Let's now look at alignment evaluation rubric. Here's the bash code for this section, starting with DPO alignment evaluation. Let's now look at balancing alignment goals. Let's now look at the alignment triangle. Here's the bash code for this section, starting with helpful. Trade-offs, too harmless, over refuses, not helpful, too helpful, unsafe, not harmless, too honest, annoying, I don't know too much, goal, balanced alignment. Let's now look at creating balanced dataset. Here's the bash code for this section, starting with 50%, helpfulness, detailed versus vague. Example mix, 500 pairs. 250 helpfulness pairs, 150 safety pairs, 100 honesty pairs. Let's now look at iterative DPO refinement. Let's now look at process. Here's the bash code for this section, starting with 1. Train with DPO dataset V1. Let's now look at example iteration. Iteration 1. Train with 300 general pairs, result, good helpfulness, poor safety. Iteration 2. Add 100 safety-focused pairs, train with 400 total pairs, result, better safety, but over-refusing. Iteration 3. Add 50 pairs showing appropriate helpfulness despite safety concerns, train with 450 total pairs, result, balanced. Let's now look at complete DPO workflow notebook. Save as notebooks was05 advanced techniques WODIE DPO alignment.ipnb. Cell 1. Set up. Cell 2. Load base model. Let's now look at DPO training checklist. Here's the bash code for this section, starting with DPO training checklist. Let's now look at key takeaways. 1. Direct preference optimization, simpler than RLHF. No reward model, no RL2. Preference pairs drive alignment. 3. Lower learning rate, 5E5 for direct preference optimization. 4. Beta controls strength of preference, 0.1 standard. 5. Balance is key, helpful plus safe, plus honest 6, iterate, multiple rounds improve alignment. 7. Works great on consumer GPUs. Let's now look at what's next. Direct preference optimization mastered. Now explore advanced low-rank adaptation techniques. Continue to. Lesson 6.3, Advanced Low-Rank Adaptation Techniques. Let's now look at additional resources. Direct Preference Optimization Paper, Rafailov et al. TRL, Direct Preference Optimization. Documentation, Anthropic's Constitutional AI, Alignment Research. Your model is now aligned with human preferences, safer and more helpful. That wraps up direct preference optimization. Well done on completing this lesson. See you in the next one.